Hi everyone. In this video, I want to talk about the spread of a data set. That is, whether it's all clumped up around one value or if it's spread out, how we can measure that and characterize it with a number. So let's start by looking at this data set. So here we just have a number of individuals. Let's see, I can see how many if I select a cell in that column and then press Control or Command and then the down arrow. It'll take me all the way to the bottom of my data set, and I can see that I have 200 individuals in this data set. So now I'll do Control and up to go back to the top. And I have some variable X that's been measured. Now I can find out about the middle of the data set by the things that we've talked about in previous videos, right? I can find the mean and the median and the mode if I'm interested in it. I'm just going to type equals average and choose that column that has the values of the variable X in it. And then I'll hit enter and I see that the average is 251. And then I can find the median too. And I see that the median is 252. And if I'm interested in other locations, we saw last time that we can talk about things like percentiles, and two special ones are the first quartile and the third quartile. And I can get those by just using those built-in functions. And our convention for our text is that we're going to use the EXC version of that, that function. So for the first quartile, I put a 1 in for the second parameter to select the first quartile, that is the 25th percentile. And for the third quartile, I'm going to do the same exact thing, except that I'm going to put a 3 in for that second parameter. Okay, so now I have all my basic, simplest measures of location. And now I want to think about the measure of spread. Now, maybe it's a good idea to just make a quick histogram of this data so that we can get an idea of what I might mean about by spread. So I'm going to insert a histogram. And since I don't really have anything exciting to say about what this data is, I'm going to just take out the chart title. And maybe I will make a few more boxes just so that I can see some more features of this data set. So maybe I'll make 15. Let's see how that looks. Could I go as high as 20 and still have something that looks good? Let's see. That looks okay. I'll leave it at 20 for now. And before I close this, I think I'm going to make a little bit of formatting along the numbers of this axis. I'm going to change it so it doesn't show any decimal places. And that way it'll look a little bit more readable. Okay, so let me close this up. And when I'm talking about spread, what I mean is like how much this data is spread out. Like how far is the bottom of the data set from the top of the data set. And there is an easy way to compute that. That's called the range. And it's just the difference between the minimum and the maximum value. And I can find the minimum value of this data set by using the min function. And I will just highlight this entire column, close the parenthesis, and it tells me that the smallest value in this data set is 198, and I can find the maximum value by using the max function, and I see that's 319. So now the range is an easy thing to compute since it is just the maximum minus the minimum. So I'll type equals, and then I can either click on or type in or arrow up to the cell that has the maximum value. Then I'll just type my minus sign, and then I'm going to arrow up to that minimum value and hit enter, and I'll see that the range is 121. So the distance from 198 to that top number of 319, that difference is 121. So we'd say the range spans 121 units, whatever those units happen to be. So another measure of spread that avoids the situation where we have outliers that are confusing our data is something called the interquartile range. Or sometimes people just write IQR. Let me make this column a bit wider. And the interquartile range is just like it's just like computing the regular range, where you take the largest value minus the smallest value, except instead of using those outward points that are all the way the max and the min, we're going to use the first and third quartiles. So to get the interquartile range, I'll type equals, and I'm going to do the third quartile minus the first quartile and hit enter. And my interquartile range in this case is 28. And the reason this can be a more useful measure of variability and spread, and the spread outedness of the data set, is because if we have some weird outlier, like maybe somebody accidentally typed 1245 instead of 245 in this data set, look what happens to the range and compare what happens to the interquartile range. I mean, first of all, our diagram changes considerably. And if I look at the values here, this range that was about 120 is now 1,000, right? So that changed a lot. But the interquartile range, I'm just using Control Z and Control Y to go back and forth between having done that and not done it. The interquartile range changes only a little bit by 0.75. Using the interquartile range as a measure of spread is a better, it does a better job of avoiding disturbances by outliers than just using the regular range to talk about how much the data is spread out. The last way we measure spread or variability in the data set is by using something called the standard deviation. And the standard deviation can be kind of a pain in the neck to calculate by hand, but lucky for us, Excel has a standard deviation built-in function. It's called STDEV. And there are two possible choices for STDEV values here. One is STDEV.P and one is .S. .P is for population and .S is for sample. So I'm going to use the sample one. Those two things would only differ by a tiny bit. Generally, we'll be using the sample one. All right, and I see that this standard deviation is about 22.6. We'll talk more about what the standard deviation means in the next section of this chapter. But for now, we can just think of it as something that tells us about how close most of the data is to the mean. So if I look at where the mean is on this graph, it's at 251. So the mean is right about here. And the value of the standard deviation, which is 22 or 23, tells me that really most of the data points are going to kind of be between here and here. So if I took that standard deviation and added it to the mean value, I would get 273. And that's about that far. So that's a really rough idea of what standard deviation tells us. But again, in the next section, we'll talk way more about it. All right, so this is how we compute 3 different measures of spread in a data set. And in the next video, we'll talk about using those measures to identify outliers so that we can eliminate those in our computations.